In question 10a, we're asked to simplify the expression. First thing I notice is there is not index here. If you don't see an index, it's automatic 2. So we're doing the square root of a negative 12, a to the 6, b to the 9th. When we simplify radicals, we're obligated to remove all perfect square factors. So one of the first things I'm going to do is I'm going to rewrite that negative 12, and I'm going to be thinking, are there any perfect squares that divide into 12? And there are. 4 is a perfect square. It divides into 12 evenly 3 times. So I'm going to rewrite 12 as 4 times 3, and negative 4 times 3, since there's a negative there. A to the 6th and b to the 9th. Now I'm going to go through and try to remove all the perfect squares that I can. The square root of a negative 4 is just a positive 2i. The reason I'm going to have positive because this one right in here, since we don't have anything indicated right here, we want the principal or the primary square root, which is just the positive square root. So we don't want the plus minus 2i, we just want the positive 2i there. So I can put that there to help emphasize it. All I want are the positives, but we don't have to put it there. The square root of 3, there are no more perfect squares in 3, so I just put the square root of 3 there. Now we're going to handle our a to the 6th. The a to the 6th, we want to take the square root of a to the 6th, and we said we can think about this as how many perfect groups of 2 are there in 6. So we're going to take that 6 divided by 2, and there are 3 perfect groups of 2 in 6. So we're looking at there's a squared times a squared times a squared, and every time we take the square root of an a squared, we got an a. So we got those a times a times a multiplied, or a cubed. It's as simple as taking a 6 divided by 2. Then I'm going to work on that b to the 9th. Now b to the 9th isn't a perfect square, but that doesn't mean we can't simplify it. What we can do is we can see how many groups of 2 there are in 9. So that means there's going to be b to the 4th. 4 times 2 is 8, so that leaves one of those b's behind underneath your radical. Okay, so the last thing I need to do, or at least at some point I got to reconcile, is do I need any absolute values? Did we take an even root of an even power and get an odd answer? And yes, we did right there in part A. So what I want to make sure we do is we put that a cubed in absolute values because we want the principal or the positive square root. I don't have to worry about the 4th power because when you raise something to the 4th power, it will automatically be positive. So that's how I simplify 10a.